Today we're going to graph inequalities with two variables. So what you do is you graph it like you normally would a line. So we're going to just pretend like that has an equal sign. I'm going to rearrange this to put it into slope-intercept form. So it'll be y less than or equal to negative 3x plus 5. So I'm going to start with my y-intercept and my slope of negative 3 over 1. And I'm going to go ahead and make my line. So since it's an inequality rather than an equal sign, we have to do one more extra. Instead of just the points on that line being the solutions, we actually have to show a whole area of points that are solutions. And the way you do that is you pick a point that's not on the line and use easy numbers like maybe 0, 0, because 0, 0 is really easy to work with. So I'm going to test this point right there, 0, 0. And I'm going to plug in 0 for x and 0 for y. So 0 less than or equal to negative 3 times 0 plus 5. Negative 3 times 0 is 0 plus 5 is 5. 0 is less than or equal to 5. My statement came out true because 0 is less than or equal to 5. That means that every point on that side of the line is also going to be true. So I'm going to shade it very lightly. If I had picked a point on the other side of the line, like maybe 4, 1, that one would have come out false, and every point over there is going to come out false. So you're telling somebody that the points on the line, as well as the shaded area, all of those points, are going to make that inequality true. Let's try another one. Before we do, a couple things you might want to remember. If you need to write this down, you may want to pause the video. We just did one like this, the second scenario. If it's a less than or equal to or greater than or equal to, you make a solid line like normal. Much like you make a closed circle when you're graphing on the number line. When you're just greater than or just less than without the equal to underneath, make sure you make a dotted line, just like you would make it an open circle when you're graphing on a number line. So we're going to do one like that next. So it's just a greater than, so I'm going to remember that this is going to be a dotted line. Okay, so we're going to go ahead and graph it. It's already in slope-intercept form. So I'm going to start at positive 1, and I'm going to do a slope of negative 2 over 1. I'm going to go up 2, left 1, and then I'm going to go down 2, left 1. Right 1, sorry. And if you can see it fine, go ahead and just leave it. If you want to make them more like dashes, that's fine. As long as you don't fill it in. You don't want to tell somebody that the points on that line work, because if I pick a point on that line right now and I plug it in, it's not going to be true. It's not going to, the left side will not come out greater than the right side. They will come out equal. So we're not telling somebody that those are true. We're saying here's your border, and then we're going to decide which side of the line does make it come out true. We can try 0, 0 again, so that's not on the line. It's a little bit below the line. So I'm going to use that as my test point again because it's so simple. So if I put 0 in for y, and I also put 0 in for x, negative 2 times 0 is 0, plus 1 is 1. Mine says 0 is greater than 1. That is false. 0 is not greater than 1. That means that that side of the line are all false. So I'm going to go to the other side of the line, and I'm going to shade that side. So any points I pick over there is going to make it true. All right, let's try one more together. Let's put it in slope-intercept form first. So I'm going to subtract 4x. I'm left with negative 3y is greater than negative 4x plus 6. And then I have to divide by negative 3. If you remember back when we did inequalities, that's a rule we have to remember. When you divide by a negative on both sides of an inequality, you have to flip the symbol. So this is going to come out to y is less than, and it looks like we're going to have a positive 4/3 slope and then the -2 y-intercept. So I'm going to go ahead and graph that. So there's my y-intercept. I'm going to go up 4 over 3. This is a dotted line again. Notice it's not an equal to, it's just a less than. So I am going to make mine a little longer so I can see the border better. And again, I'm going to use 0, 0. Don't forget, you can use any point you want. You can use 1, 1, you can use 5, 3, whatever you want, as long as it's not on the line. But let's do 0, 0. Okay, so if I plug 0 in for y, and I plug 0 in for x, left side is still 0. 4/3 times 0 is 0, minus 2 is -2. 0 less than -2, that is false. 0 is greater than -2. So 0, 0 doesn't work, which means that side of the line is false. This side of the line would be true.